Hello everyone, this is Decrypt and this is part 4 of the Buffer Overflow for OSCP video series. In this video, I'm going to show you how to find the jump address, and if possible, we will also look into converting all we learned so far into a reversal. If not, that'll be on the next video. So let's continue. So in our last video, we were able to find the bad characters, and we also added extra characters uh, to avoid in this file called avoid.txt. So now I'm going to look into finding the jump address. So let's start. When we execute a program or a shellcode in the program, we want to make sure that the EIP is pointing to our shellcode because that's the return address, right? So in our scenario, when we see, let's re-execute the bad.py to convey my point here. So going back, in our program here, when we have the 4242s, the execution is going to jump to this address because that's what is written in the address area pointed by EIP, right? So if you want to execute a shellcode, you need to find the address of the shellcode and then write that address in this EIP, right? But in an ideal scenario, it's really impossible to find out where in memory your shellcode is unless you're following this very easy technique that I'm going to show you, right? So we know that our bad characters were here in the stack after the B's, right? So the B's are the ones that we're gonna that are the ones that are written in the address pointed by EIP. So basically, we have A's, we have EIP address, and we have our bad characters. So previous to that, we had our C's here. This is an ideal place to write your shellcode. Why? Because we know exactly where this would lie, because this is basically stack. The ESP at the point of this crash is pointing to the top of the stack, and the top of the stack is the start of our bad characters, right? So if we find a way to point the execution back to the stack, back to the address pointed to the ESP, then we might be able to achieve the shell execution. So how do we do that? So in assembly, there is this instruction which is jump ESP, which basically means that jump the point of execution to the ESP and continue executing whatever is there or whatever is pointed by the ESP, right? So if we are able to find the address of this instruction in the program and then write that address in the EIP here, we might be just able to continue executing our shellcode, because once EIP is written by jump ESP's address, it's going to go to that address, execute jump ESP, and as per the instruction, it's going to jump back to the ESP here. And in ESP, the ESP is pointing to the top of the stack, so it's going to go to the top of the stack here. And here we have our shellcode, and that is going to get executed. So that's as simple as that. So how do we find the jump ESP address in the program? So we are going to use this module, search from Mona. So let me restart this application real quick. And you invoke Mona by typing exclamation, and you type modules. So once you type that and enter, you will have this output called module info, and it is going to list all modules or libraries or program code that is being currently loaded into the memory for the execution of this program, right? Out of that, we are very much interested in the ones that don't have any kind of memory protection, such as ASLR, address space layout randomization, NX, which means not execute. So we don't want to have a not execute on the module. So we are looking for a false on across all these different protection levels. So one module that satisfies all our conditions here is the brainpan.exe, which is our primary program, right? So this is easy, and we were able to identify the one-off, um, the outlier here, and we know that we need to be searching for the jump ESP here. So let me continue, and then I will show you how to find if you have another module, say a DLL that is also satisfying your condition. So continuing with that, so once you find that, the next step is to click on E in the debugger, so which will show you all executable modules. And again, our job here is to find the module that was previously listed by this command in here. So here we have the brainpan.exe on the top. So double click on that. It is going to take you to the very first instruction in this program, right? Once you're here, right click, search for command, and we know that we want to search for jump ESP. Once you click find, it is going to start finding the different addresses where these instructions are present. So let's take the first instruction, the first address that is showing up here. So can we take this address and put it right into the EIP, right, in the place of our Bs? Before that, we need to make sure that this address here is not having any bad characters that we identified in our previous step. So let me write it down, that the address that's showing here. So we write it down in bytes. So a byte is 2 characters that you're seeing there. So it's 4-byte long address. And we want to make sure that it doesn't have any bad characters. So let's go back and take a look at the bad characters we noted in our previous video. So we have 0, 0, 0, 0A, D, and 20. And this does not have any of those characters. For example, hypothetically, if this had this address here, then we might not be able to use it. That's because, like I said, any bad character is going to crash your payload or even your string that you're going to send in memory, and that will corrupt all your subsequent bytes. So in our case, we got lucky and we don't have any bad characters there. So this might be just the address that we are looking for. Our job now is to note this down in reverse format. So what do I mean by that is write this down in reverse, F3, 12, 17, 31. So we want to have the hex notation here by \x and then delete the spaces. So copy it, make sure you noted it down right. So it should be F3, 12, 17, 31. F3, 12, 17, 31. So next step is to copy the bad characters.py script to a new script called jump.py. I have already done that, so I'm going to open it in Nano and place the address that we just identified in the place of B's. So this should be our jump address. So what we are doing here again is sending 524 A's until we overwrite the EBP. And the next address after EBP is the EIP, and we are going to write that EIP with this address, which means asking the CPU, hey, please go to this address right here and continue to execute the instruction present there. And that instruction will be the jump ESP, and it's going to jump back to the area where we have C's. So finally, our shellcode is going to be here in the place of C's, but let me just have it uh, for this video without modifying anything. So I'm going to save this. And one important step is to set a breakpoint at this address. So go right click, breakpoint toggle, so that we will know if what we did worked or not. So confirm that breakpoints are present by clicking view breakpoints, and we have the breakpoint. So go to the CPU window again, and let's execute this address, this latest script that we created, and see if the execution of the program hits that breakpoint. So we executed it, and as you can see, we have breakpoint at 31, 17, 12, F3, which is the one we set. So we for sure know that we are able to place the jump ESP address at the EIP, and it's indeed working. And once you click play, it's going to go and try to execute the C's here. I'm going to click play here, and it's not doing anything because it doesn't make any sense to the program, right? So that was as simple as that, finding jump address. So this was too easy for our demo, obviously. So in your exam scenario, you might not get this easy binary. So let me open another binary for this example, just to show how to find the jump ESP address if you have another additional module, right? So here I have used the vuln server.exe. So let me click play, and I'm going to type mono modules and click enter. And as I mentioned earlier, if you see, we have two modules that satisfy our condition, right? One is the vuln server.exe, and the other one is the ESS FUNC essential function, I guess, .dll. So it was intentionally created with the jump ESP address for us to take advantage of, right? So we can search for jump ESP in two of these modules. So let's click the E button here, and we find that both of our modules that we might target is present in executable list. So executable just means that that module can be executed, right? So here I'm going to use the DLL because that's the one that I have not shown you before, and double click, and it takes us to the DLL here. As usual, go right click, search for command jump ESP, and we can find the jump ESP's address here. So that's all. That's all for this video. Actually, I hope you understood really how to find the jump address. I'm going to stop this video right now and make the part where I'm going to execute a shell in the next video. Until then, decrypt.